Hey guys, Mr. Bouchard here, and I'm here to talk to you with the start of the second topic. First, before I get started, just want to show you this figure here. This is to show you the shape of the Earth. Obviously, from space, it looks pretty spherical. All right. However, there are slight differences between the equatorial diameter, which is around the waistline of the Earth, and the polar diameter if I go from pole to pole. So which diameter is larger? The answer to that question is the equatorial diameter. Around what part of the Earth is it widest? Equatorial diameter. What does this diagram say about the shape of the Earth? Well, it's not a perfect sphere. All right, there actually is a term. All right, and I am actually going to write that term on the board. Just give me a second. So that term, you guys should actually know. It's called an oblate spheroid. All right, it basically says it's not a perfect sphere. It's slightly elongated around the equatorial region, but not enough that your naked eye would actually be fooled by it. All right, in general, this picture, all right, this would be called what we call a model. All right, it's one of the vocabulary terms in the chapter. We're going to be looking at many models and different representations of things in this chapter. All right, so this is just one example. So basically, what we're going to be looking at in this chapter is measuring Earth. We're going to be looking at different ways to measure Earth or talk about Earth, and that's what we're going to cover. All right, so first I want to start out with a little experiment done by a scientist actually a long time ago. He was basically an astronomer named Eratosthenes, lived over 2,000 years ago, found the circumference of the Earth. And you're going to say, what? Didn't they think the Earth was flat? Well, for some reason Eratosthenes looked up at the other things in space and basically saw them as spheres, so he believed the Earth was a sphere also. So he used the angle of the sun and distances between two cities and was able to mathematically calculate the circumference of the Earth. And so, genius thing. He was well before his time, and we found out later he was pretty close in his calculation. He was off maybe a little bit because accuracy in measuring distances, but overall, he did a great job in his discovery. All right, and that's the Greek people that discovered this years ago. Also, other proofs that the Earth is round. Okay, so one would be that ships seem to sink below the horizon when they move out of sight. All right, so just imagine two ships passing each other. All right, eventually they're going to go out of view, because the furthest you can see really along the Earth's surface is around 15 miles or so. And when the ship goes out of view, it looks like it disappears, but it's really just sinking below your view below the horizon. Okay, navigators like Ferdinand Magellan circumnavigated the world, all right, so they've gone all the way around. He actually didn't make it. He actually unfortunately died somewhere over in the Indies over here, Indonesia. But his crew did make it, all right, all the way around the Earth, right? And obviously he's not the only one that's done that. And now planes do it, of course. Moon and other planets are spheres. Okay, so that was an obvious one. That's what the Greeks even looked at. Photos from space, all right, so once we got in space, took pictures from satellites and also from our spacecraft. Beautiful pictures. Curved shadow of the Earth and the Moon during a lunar eclipse. You're going to say, what? Okay, well, the Earth's shadow is cast on the Moon during a full moon, and that's what the lunar eclipse is. All right, so we'll learn more about that later in the year. And then also positions of stars relative to the horizon changing as an observer moves north and south. Right, great example of that, what the explorers used to use to actually track themselves on the globe, which is Polaris, also known as the North Star. All right, so we'll be talking more about that soon when we get to latitude and longitude. Okay, also important are the spheres of the Earth. So we have the atmosphere, which is the gases above the Earth's surface, hydrosphere, which is the liquid layer of water, which covers around 70% of the Earth's surface. So we're mostly, that's why they call the Earth the water planet. Lithosphere is a layer of rock that forms the outer shell of the Earth's interior, and the upper part of that lithosphere is called the crust. Right, so we'll go more into detail in a future topic about the lithosphere. And okay, so the only sphere we're not talking about here is the biosphere, right, which you guys will be doing in living environment in the future, or bio. And then we have the atmosphere, obviously the gases, hydrosphere, water, any, and it could be fresh water or salt water we're talking about. And then lithosphere, they show a volcano here because, you guessed it, volcanoes actually add to the lithosphere, right? And these make up the Earth system, and we'll be talking more in detail about each of these as the year goes on. Okay, and then this is just a table from the text showing you the relative densities. So you guys know rock is more dense than water, which is more dense than gas. So either way, you know them in terms of density compared to each other, really. Okay, and lastly, this is a reference table chart. It's right on the front. Okay, and this basically goes through the crust, the hydrosphere and troposphere, and tells you what elements make them up. Okay, and elements, you may know already from previous classes, they're basically the chemical building blocks of substances. All right, and some substances will be made of multiple of these, some will be made of one, depending. And in general, so if we look at the crust, okay, silicon and oxygen make up most of them by mass and by volume. All right, mass is the amount of matter, as you guys know. Volume is the amount of space the object occupies. So you notice oxygen takes up the most mass and volume on the Earth's surface of the crust. And you can get the relative of all the other materials also that make up the crust. Okay, and the section that says other, there's other trace elements, but they make up very little, so they don't list them here. Water, hydrosphere. Okay, so you guys know hydro, water. So hydrogen is 66% of the hydrosphere, 33% is oxygen. And you guys know the chemical formula for water is H2O. 2 hydrogens for every 1 oxygen. And that makes sense because the ratio is here. So there's 2 hydrogens, or 66%, for every 1 oxygen, 33%. And then lastly, troposphere, which is the air we're breathing currently. It's also where the weather occurs, the lower layer of the atmosphere. So the lower layer of the atmosphere is made of 78% nitrogen and 21% oxygen. All right, everybody always thinks the only thing we're breathing in is oxygen. All right, that's not the case. Air that we breathe has mostly nitrogen in it. However, we don't need the nitrogen, so we just re-exhale that out. Nitrogen makes up most of air, and then 21% oxygen. So we need that ratio. Even if we fill up an oxygen tank, it's not 100% oxygen. It's going to be 21% oxygen, because that's what our body needs actually to breathe. And then the other 1% are all the other gases: carbon dioxide, nitrogen, nitrogen dioxides, whatever else is in the air pretty much that you smell. So this chart could be used to answer some questions, so I'm going to give you guys some practice questions on this. And I thank you guys for tuning in, and we'll continue through the chapter. So thanks for coming. Bye.